in this example, does it converge? The integral from 1 to infinity of x divided by the square root of 1 plus x to the 6th dx. Do you want to integrate that? I mean, using the technique I've shown you so far, you'd have to eventually find an antiderivative for that integrand, wouldn't you? Wouldn't you like to avoid that? If all you're asked is whether or not it converges, wouldn't you like to avoid that? That's what comparison's all about. So there's 3 steps you want to do in these problems. Step number 1, you want to figure out what you're going to compare the integrand with. The integrand is x over the square root of 1 plus x to the 6th. And oftentimes you want to keep this result with the integral of 1 over x to the p in mind. As you're figuring out what to compare it to, you have to come up with the function you're going to compare it to. And you're going to want to make it a simpler function in case you have to integrate it. So if I deleted this one, so picture deleting this one, then I think I can end up with an integrand, a function of the form 1 over x to the p. Do you believe that? So that's my train of thought here. And in fact, I'll be creating a bigger function. Now, do you believe, so I'm deleting the 1 and making it x over the square root of x to the 6th. Do you believe that inequality right there? What did I do to the denominator? I made it, by deleting that plus 1, I made the denominator smaller, right? But that makes the overall value of the fraction bigger, okay? And certainly, when x is only going from 1 to infinity, certainly both of these functions are big. Well, actually, I don't need the or equal to. They're both strictly bigger than 0, but the or equal to I kind of put in by habit. Right? Would you agree that that's true? That's step 1. Well, we want to simplify that guy on the right, though. What's the square root of x to the 6th? X to the 3rd, and then what's x over x to the 3rd? So that's the idea. I had in mind I could compare this given integrand with something of the form 1 over x to the p, so that I get a result from this note that I've put right here. Okay, so that's the comparison part, step 1. Step 2, you want to figure out what the integral, same limits of integration, the integral of the simpler function is doing. Does it converge? Does it diverge? In this case, we're hoping for convergence. So step 2, you could maybe have a connective word right now. The integral from 1 to infinity of 1 over x squared dx, I know that converges. The above note, you're able to assume what the above note says is true. You don't have to prove it. It's proved as example 4 in your book if you want to look at that. It wouldn't be that hard to do it on your own, though. So what's p in this situation? 2. So how do I know it converges? Because this is actually a theorem. You can prove it. It's proved in example 4. Because I know this sort of integral converges for p is greater than 1. And of course, p is equal to 2. So how do you justify that conclusion, that integral converges? You would just say p is equal to 2 and note that it's bigger than 1. That's all I need for justification there. Okay? That's all I need for justification. And now you want to make a conclusion about the given integral. What's your conclusion? So the given integral, the integral from 1 to infinity of x over 1 plus x to the 6th square root dx converges by, you could say by comparison theorem or just by comparison if you like.